Okay, this is section 5.7, part 2. We had just seen how we could derive the derivatives for the arc trig functions, the inverse trig functions. And we're about to start example 4, where we were going to put those to use to find some derivatives. So the first question is, what is the derivative with respect to x of arc sine of 2x? Well, if you look at the answer we got, that's going to be 1 over the square root of 1 minus the input, which is 2x, quantity squared. Then the chain rule says we then have to multiply by the derivative of that inside function. And so that's 2 over the square root of 1 minus 4x squared. Okay, next one. B, the derivative of inverse tangent of 3x. Okay. So this is 1 over 1 plus the input, which is 3x squared, times the derivative of the inside function, 3. And so this is 3 over 1 plus 9x squared. C, the derivative with respect to x of sine inverse of the square root of x. So that's 1 over the square root of 1 minus the input, which is square root of x, squared, times the derivative of the inside function. Remember, square root of x is x to the 1/2. So its derivative is 1/2 x to the negative 1/2. And so this will be 1 over 2, and then x to the negative 1/2 is square root of x in the denominator, times the square root of 1 minus, and then the square root of x squared is x. Then if you multiply those two radicals to simplify, you'll distribute the x and you'll get x minus x squared under that radical. Okay, part D. The derivative with respect to x of arc secant, so I'll call that secant inverse, of e to the 2x. Okay, so if you look at that one, that's 1 over the absolute value of the input, absolute value of e to the 2x, times the square root of the input, e to the 2x, squared, minus 1, and then because of the chain rule, we have to multiply by the derivative of the inside function. The derivative of e to a power, coolest function ever, is that power of e times the derivative of the inside function. The derivative of the exponent 2x is 2. And so this is 2e to the 2x. The absolute value of e to the 2x, since e to the 2x is never negative, nor is it ever 0, the absolute value is superfluous, so I can take it away. Power and a power, you multiply the exponent, so that will be e to the 4x minus 1, and the e to the 2x's cancel, leaving 2 over the square root of e to the 4x minus 1. All right. So if you turn to the next page of notes, the review of basic differentiation rules. An elementary function is a function from the following list, or one that can be formed as the sum, product, quotient, or composition of functions in the list. The algebraic functions are polynomials, rational functions, which is a polynomial over a polynomial, functions that involve radicals, and then the transcendental functions are log functions, exponential functions, trig functions, and inverse trig functions. And so if you look at the next couple of slides, it's a complete list of all of the derivative rules that you should know at this stage. So that's a very handy set of things to kind of keep an idea of what they are. Now, none of these should surprise you at this stage. You should know all of these derivative rules. Nothing strange in them at all. We've talked about every single one of them. So make sure that you still know them and that you've mastered them, and when needed, you can use them. All right, that ends this lesson. I will see you in class.